Hello. In this video, we're going to be talking about complex numbers again. And complex numbers are something that we're capable of graphing on a coordinate plane. It's a different coordinate plane than what you're used to. This is called the complex plane. So if we have a plus bi, we have a real component and an imaginary component. A is real, and then b is the imaginary component because it is multiplied by the imaginary unit I. So we can represent this as the point A comma B. The horizontal axis, instead of being the x-axis, is now our real axis. And then what was used to be the y-axis, the vertical axis, is now our complex axis. So in order to graph things like 3 minus 2i, like we're looking at in number 1, we're going to look at this as the ordered pair 3 comma negative 2. So we're going to first move to the right 3 units, and then we'll go down 2 units. And so our point 3 minus 2i will land at that spot. So this will be 3 minus 2i. And we can write this and label it either as 3 minus 2i like that, or simply as the ordered pair 3 comma negative 2. All right, the next one is negative 1 plus 5i. So as an ordered pair, we can look at it as negative 1 comma 5. So we would just go left 1 and then 1, 2, 3, 4, 5 up. And again, we can look at this as either negative 1, 5 or as the number negative 1 plus 5i. Okay, so let's talk about distances involving these. So the absolute value of a complex number, remember absolute value is the distance away from 0. So in this case, it's our number's distance away from 0, 0. So if we wanted to find the absolute value of some number z, which is complex, so I've also written it out as a plus bi, we could do the absolute value of a plus bi, which is just the same as the square root of a squared plus b squared. Now if I were to just draw a rough sketch of this, and I'll do this for number 3, the 3 minus 6i. 3 minus 6i, 1, 2, 3, and then we go down 1, 2, 3, 4, 5, 6. We'll have that point right there. The distance from the origin out to that point is what we're trying to find. Now we've moved over 3 units and then down 6. So the distance that we're trying to find here, that is just the hypotenuse from a right triangle, which means we can do the Pythagorean theorem. And so really we're looking at your 3 squared plus the negative 6 squared, and that would equal z squared, but we could just square root both sides to get z by itself. And so to evaluate this, 3 squared is 9, negative 6 squared is 36. So our distance is the square root of 45, which we can break down. That's root 9 times root 5. So z, our distance is 3 square root of 5. So the absolute value of a plus bi is 3 times the square root of 5. It's also the distance from 0, 0 to the complex number 3 minus 6i. Okay, so that's your crash course on the complex plane. For now, we are done.